Today, we are going to discuss the compliance operator. My name is Aleš Nosek, and I am the software practitioner located in San Diego, California, helping you navigate the world of Kubernetes. This video is part of a series about Red Hat ACS. I will have links to all parts of this series down below the video. There are two compliance implementations used in Red Hat ACS. There is the built-in compliance, and then there is the compliance operator. We discussed the built-in compliance in the previous video. In this video, we are going to focus on the compliance operator. Compliance operator can be installed on OpenShift via OLM, Operator Lifecycle Manager. To perform compliance checks, the compliance operator uses the OpenSCAP tool under the hood. You may remember using OpenSCAP on Red Hat Enterprise Linux. The tool takes as an input a set of compliance rules, and it evaluates the target system against these rules. The compliance rules are developed in the Compliance as Code project, and you would find them in their Security Automation Content Git repository. I will include the link to this repository down below the video. For Red Hat Enterprise Linux, the rules checked various configuration settings in RHEL. For OpenShift, on the other hand, the rules check the Kubernetes API objects, as well as the configuration of individual cluster nodes. The compliance operator comes with rules that were designed to work with OpenShift 4 and Red Hat CoreOS. The operator supports several compliance benchmarks, like for example the CIS, NIST, and others. The checks performed by the compliance operator can be divided into two categories. The first category are the platform checks. These checks evaluate the cluster configuration. They look at the various Kubernetes API objects. These checks are equivalent to what Red Hat ACS built-in compliance called the cluster checks. Second category of checks provided by the compliance operator are the node checks. Node checks function the same way as they did for Red Hat ACS built-in compliance. They check the configuration of individual cluster nodes by scanning the file system of the nodes. In contrast to Red Hat ACS built-in compliance, the compliance operator doesn't support any deployment checks. That means that the compliance operator does not evaluate the workloads, the configuration of the workloads that are running on the cluster. The compliance operator supports profile tailoring. Profile tailoring allows you to customize the compliance scan so that it works better in your environment. I will show you the profile tailoring in action later in the video. Last feature of compliance operator that I wanted to discuss is the automated remediation. With automated remediation, the compliance operator can automatically fix some of the issues found. It can patch the Kubernetes API resources to make them compliant, or it can create machine configs to fix the compliance issues on cluster nodes. The automated remediation is an interesting feature. However, I recommend against using it. Instead, any cluster changes should be made through a process like GitOps, where you first check them into Git and review them. Then you apply them into lower clusters where you test them. And after the changes were verified, you can promote them into higher level clusters. This process reduces the risk that the change will break your environment. When working with the compliance operator, you will be using several Kubernetes custom resources. They are depicted in this diagram. This diagram can be found in the documentation of the compliance operator on GitHub, and I will include the link down below the video. The first custom resource I would like to talk about is the profile bundle. The compliance operator creates profile bundles automatically after you install it. I installed the compliance operator on a test cluster, and you will find it in the namespace OpenShift Compliance. The version I'm using here is the Compliance Operator 1.4.0. The Compliance Operator created two profile bundles. There is a bundle for the OpenShift 4 and a bundle for the Red Hat CoreOS 4. If we peek inside of the OpenShift 4 profile bundle, we will find that there is a link to a container image and a file, an XML file, which is stored in the root of this container image. This file is an XML data stream. It defines the compliance profiles and rules according to which our environment is going to be scanned. The compliance operator parses the XML data stream and creates the respective profiles and rules as Kubernetes custom resources on the cluster. We can take a look at what profiles are available to us. Note that on OpenShift there are two API groups which both use the same name of the resource, profiles. And so let's make sure we pick the compliance profile resource. There are many profiles to cover the different compliance standards. Compliance profiles typically come in pairs. For example, for the CIS standard, you will use the OCP4 CIS profile. This one will scan the Kubernetes API resources. And in addition to that, you will also use this OCP4 CIS node profile to scan the OpenShift nodes. Similar situation is with other standards. For example, for PCI DSS, you would run a scan using the OCP4 PCI DSS profile, and you will also use the OCP4 PCI DSS node profile. A compliance profile is just a collection of rules. We can, for example, take a look at this OCP4 CIS profile here. And if you look inside, now we'll scroll up here, we'll find out that this profile is for scanning product type platform, which means that it is for scanning the Kubernetes API resources. And here we can see the collection of rules which will be executed when the scan based on this profile is running. Let's take a peek at one of the rules here. For example, the OCP4 audit profile set rule. You can look at the definition of this rule. The title of this rule is ensure that the cluster's audit profile is properly set. And there is also a rationale for this rule, which pretty much says that we should have the Kubernetes audit logging enabled on our cluster so that we can detect potential unauthorized access. If I scroll up, then we can find a section called description. The description section includes additional detailed information about this rule. And then there is also the section called instructions. I find this instructions section especially useful because this section reveals what information is this rule actually checking on the cluster. So it reveals what this rule is looking for. And we can see in this particular case that the rule based on this command would retrieve a resource of kind API server with the name cluster. And then within this resource, it will look at the field under spec audit, and the field is profile. So it will retrieve the value of this profile field, and it will check that value against the compliance standard. I can copy the command and run it on my cluster so that we can see that the current value on my cluster of this field is all request bodies. The question is this value compliant with the standard or not? Let's scroll up one more time to take a look at the instructions section of the rule. What does it say about the accepted values for this rule? It says here, make sure the profile return, so the profile configured on the cluster, matches the one that should be used. Unfortunately, it doesn't say specifically which values are the ones which should be used. In other words, which values are the ones which will be accepted by this rule. Normally, the instructions section will tell you and guide you to what you should configure or modify on your cluster to become compliant. In the case of this rule, the guidance is not complete, and so I had to dig a little bit deeper to find out. Eventually, I looked up the definition of this rule in the XML data stream that I told you before. And in this XML data stream, I learned that the rule is parameterized. It takes a single parameter, and this parameter is the value of the profile to be used. You can list the rule parameters available to you by typing ocget variable in the OpenShift compliance namespace. There are many parameters available which are used by different compliance rules. In the XML descriptor, I learned that the name of the parameter that is used by our rule is the OCP-var OpenShift audit profile. And we can take a look at the definition of this parameter. ocget variable. Let's take a peek. The definition of the parameter includes a description. The description details what the meaning of the parameter is. And then there is a section called selections. Selection section includes the available values which this parameter can take. The options here are all request bodies, default, and write request bodies. If no selection is made, then the default value should be the default. However, I learned from the XML data stream that this value is overridden there, and so the real default is actually the write request bodies. The rule, as it is now, will fail to validate our cluster. The rule is accepting a value of write request bodies for the audit profile. However, if you remember, our cluster is configured with all request bodies. We will see the scan failure later in the video, but before that, let's go back to the diagram and continue our discussion about the Kubernetes custom resources used in the compliance operator. So far, we've talked about the profile bundle. The profile bundle is a custom resource which is created automatically by the operator. The profile bundle includes a link to an XML data stream that is downloaded by the operator and parsed. And based on the information in this XML data stream, the operator then creates the profile objects, so the compliance profiles. When preparing for the compliance scan, you will pick a profile that matches your desired compliance standard. Alternatively, you can use a tailored profile instead of the profile. Tailored profile allows you to adjust a factory profile so that it fits your environment. In addition to picking a compliance profile, you will also need to prepare the scan settings for your scan. You can use the default scan settings which come with the operator. You will find them in the OpenShift compliance namespace. Scan settings define some technical parameters for the scan. Let's take a look at the default scan settings. I will scroll up. The scan settings, they include a section that configures the raw result storage. The compliance operator creates a persistent volume, and it will store the raw scan results on this volume. In our case, it will create a volume in read-write once mode, and the volume will have a capacity of 1 gigabyte. The compliance operator will store up to 3 raw scan results on this volume. Any additional scan results coming will cause the rotation, the deletion of the oldest scan results. So if you want to save the scan results for your records, you will need to make sure that you copy them out of the persistent volume before they are rotated. Another option here in the scan settings is the scan tolerations. The scan tolerations configured here will be propagated to all node scan pods. In particular, this configuration of the tolerations will make sure that the node scans will run on all cluster nodes, regardless of what taints these nodes were configured with. Another scan setting is the schedule. The compliance scan will run immediately after we create it. In addition to that, it will also run periodically based on the cron tab specified here. In this particular case, the compliance scan will be executed every day at 1 o'clock in the night. The compliance operator will create the Kubernetes cron job that will do the triggering. The last scan setting that I would like to discuss in detail is the list of roles. This list of roles pertains to node scanning. When scanning the cluster nodes, the compliance operator runs the checks on every node in the cluster. If the compliance operator would present to you the check results for every single node, then you would realize that the check results would be likely the same for the nodes which have the same role. The reason for it is that the nodes with the same role are typically configured consistently, for example, using the machine config operator. Because of this, it makes sense for the compliance operator to aggregate the results and present a single result for all nodes with the same role. The list here configures the node roles for which the check results will be aggregated. The results aggregation is good as it makes the results more concise. However, for the aggregation to work, the results being aggregated must really be the same. If it happens that two nodes with the same role yield a different check result, then the aggregated result won't read pass or fail, but it will read inconsistent. If your compliance scan results show inconsistent, then you will need to adjust the list of roles. Now, you don't need to necessarily add all node roles which you use in your cluster to this list. For example, in my cluster, I have some nodes which have the role infra, and I don't need to list this infra role in the role list for the scan settings. The reason for that is that if you look at my machine config pools, you will realize that there is no special machine config pool that will be configuring the infra nodes in some different way than the worker nodes are. And so I don't need to specifically add the role infra into the list. Instead, the infra nodes are configured the same as any other worker node, and that means that the node scan for my infra nodes and worker nodes will be exactly the same and can be aggregated. Now that we reviewed the scan settings, we can create a scan setting binding object. In the scan setting binding, we list the compliance profiles that we want to use for our scan, and we combine them with the scan settings that will be used for the scan. After we create the scan setting binding, the compliance operator will generate a compliance suite object. The compliance suite includes a list of scans to be executed along with their scan settings. After the scan is complete, the compliance suite will also, in the status field, include the overall scan result. For each scan in the compliance suite, the compliance operator also creates a separate compliance scan object. The compliance scan contains a copy of the configuration of a single scan, and it also tracks its result. As soon as the compliance scan object is created, the scan process begins. In the next section of the video, I'm going to create a scan setting binding object to perform the scan of the cluster. I prepared a scan setting binding object, and in there I'm using two compliance profiles. Both of them are for scanning my cluster according to the CIS standard. I'm using the profile which is the OCP4 CIS for scanning the Kubernetes API objects, and the profile which is called OCP4 CIS node for scanning the cluster nodes. The scan will use the default scan settings, which we reviewed before. As soon as I apply my scan setting binding to the cluster, the compliance scan will start. I'm still in the OpenShift compliance namespace. If I take a look at the pods which are running here, I can see that there are many new pods coming up. These 10 pods are scanning the cluster nodes. There is one pod scheduled and placed on each of the cluster nodes. The pods used a host path volume to mount the root file system of the node into the pod, and then the pod runs OpenSCAP to scan this root file system. In addition to that, there is a separate API cheks pod. This pod scans the Kubernetes API resources. First, it runs an API resource collector, which will make API calls to Kubernetes to retrieve the resources that need to be scanned. These resources are saved on the local file system in the pod. After that, the pod runs OpenSCAP, which will scan the API resources stored locally on the local file system in the pod. The scan took several minutes. We can take a look at the result by listing the compliance suite object, which was created by the operator. We can see that our CIS compliance suite is complete, the scan is complete, and that the result is that our cluster is not compliant. The compliance operator also created compliance scan objects, and if we list them, then we can see the results of individual compliance scans, which are part of the compliance suite. In our case, we have 3 compliance scans, which are complete. And there's the first compliance scan, which is for scanning platform. And then there are 2 more scans, which are for scanning cluster nodes. There is one scan for the role master and one scan for the node role worker. We can see that none of the scans was successful. We are non-compliant in all cases. I switch to the web console of our OpenShift cluster. The compliance operator comes with Prometheus metrics and alerting rules, so that when we have a compliance scan failing on our cluster, we will receive a Prometheus alert. As our compliance scan is scheduled to be performed every night, We will be notified within 24 hours if our cluster runs out of compliance. Let's now go back to the diagram that depicts the custom resources used in the compliance operator. In the terminal, we have seen the compliance suite object showing the overall result for all the scans in the suite. And we have seen the individual compliance scan objects showing the results, compliant or non-compliant, for the individual scans. In addition to that, the compliance operator will store the raw scan results in a PVC volume. You can download those results from there. You can also use OpenSCAP tool to generate a HTML report out of these results. During the scan, the compliance operator also creates the compliance check results and compliance remediations. We are going to look at these objects next. Back in the terminal, I am still in the OpenShift compliance namespace. I can now take a look at the compliance check results, CCR. And there is a laundry list of all checks which were run during the compliance scan. And for each individual check, we can also see what is the result of it. There are some checks which pass, which is the most of them. There are some checks whose result is manual, which means that this check is not automated and you will need to manually check your compliance. And then there are some checks which failed, and we'll be looking at them next. I will list just the failed checks, and we can see that there are about 9 of them. So there are 9 failed checks here on this cluster. Let's peek at the audit profile set check result. If we look inside of this object, we will find out that the definition of this object is pretty much the same as the rule that we have seen earlier in the video, with the difference that now there is a status field which holds the check status. For some of the failed checks, the compliance operator is able to generate compliance remediation objects. We can list the remediations created by the compliance operator. There are 2 remediations. Each of them will fix one of the failing compliance checks. Let's take a look at the audit profile set remediation. Inside of the remediation object, the audit profile set, we can find the spec section, and within this section there is an object field, and this field holds the Kubernetes patch. This patch, when applied to the cluster, will make the rule which was previously failing, it will make this rule pass. In our case, this patch just simply sets the audit profile to the value write request bodies. I will list the failing checks one more time. In this part of the video, we are going to walk through the failing checks and we will resolve them. The first check is failing because the etcd encryption is not enabled on this cluster. I will show you the remediation in the new console window. To fix the encryption issue, we can just enable the encryption on the cluster by applying the following patch. It just sets the encryption type to the type we want to use. The next failing check is the audit log forwarding enabled. This check looks for a cluster log forwarder resource, and inside it looks for the setting that makes sure that the audit logs from this cluster are forwarded outside of the cluster. I'm going to resolve this rule by installing a cluster logging operator and enabling the log forwarding. In the case that you are using other type of forwarding, like for example you are using a Splunk collector, then you can just instead disable this rule. The next failing check is the audit profile set check. We encountered this check before. To resolve this check, we will need to create a tailored profile, and I have the tailored profile definition in here. This tailored profile modifies the OCP4 CIS profile that comes with the compliance operator, and it modifies it so that it sets the variable OCP4 var OpenShift audit profile. It sets this variable to the value all request bodies. The default value of this variable is write request bodies, which doesn't pass in our cluster, and so we are allowing that the rule would look for all request bodies instead. The next failing rule is the configure network policies namespaces. This rule checks that in each namespace that is not starting with the word OpenShift or Cube, or it is the default namespace. So in each such a namespace, there is a network policy configured. The idea is that the workloads that you deployed into these namespaces should be protected using the network policy rules. To resolve this failing rule, I'm just going to create the missing network policies. The next failing check pertains to the kubeadmin user. This user is created on the cluster during the installation. After you configure your cluster to use a proper identity provider, then the kubeadmin user is no longer needed. This kubeadmin user also has cluster admin privileges, so it is better to completely remove it. You can disable this user by deleting the kubeadmin secret, which is located in the kube system namespace. The next two rules check the file permissions on the file system of OpenShift nodes. They found that the files in etc cni netd directory have their permissions set too loose. As I investigated the issue, I realized that the files with loose permissions are actually delivered as part of the RPM package, which is part of CoreOS. To resolve this issue, I filed a bug report. While the bug is being worked on, I created a tailored profile and disabled this rule. The last two rules focus on the configuration of allowed image registries for your cluster. You should configure a list of registries from where the images can be pulled from, and also a list of registries from where you allow image import. To resolve this issue, I created a custom image registry configuration. In here, I listed many of the public registries just to make it work for now. The idea is, though, that you will include in this list only the registries that you can trust. In addition to making all the cluster changes that I described and that make the cluster more compliant, I'm going to use the tailored profile for my next scan. Let's take a look how the complete tailoring looks like. We are having a first tailored profile, which is tailoring the default OCP for CIS profile. And then we have a second tailored profile, and this one is tailoring the default OCP for CIS node profile. Now, because we want to use these tailored profiles for our next scan, we are creating a scan setting binding object where we refer to those two profiles. We otherwise use the same scan settings, the default scan settings that we used before. Before starting the scan using the tailored profile, I deleted the old scan from the cluster so that the old results were deleted as well. I can now start a new scan by applying the two tailored profiles and the scan setting binding to the cluster. Let's take a look at the status of the scans. They are just now launching, and I will pause the video here and wait until the scan is finished. After several minutes, the scans are now complete. I can take a look at the list of the compliance check results. I can get a list of all the results. And if I grab for the failed results again, I can see that there are no longer any failing compliance checks now. Red Hat ACS watches the compliance operator custom resources. It collects them and stores them in its database. After I completed a scan using the compliance operator, I can now go in Red Hat ACS dashboard, go under compliance and rescan my environment. And after several moments, we will see that the compliance operator scan results will also show up in the Red Hat ACS UI. They are right here. If I would now download the compliance scan results in CSV format, I would find there the compliance operator scan results included as well. Let's review what we covered in this video. We discussed the compliance operator. The compliance operator leverages the well-known OpenSCAP tool, and it uses the security content that is provided by the Compliance as Code project. The compliance operator comes with scans, which are directly designed to work great on OpenShift 4 and Red Hat CoreOS. The operator implements two types of checks. There are the platform, also known as cluster checks, and there are the node checks. The platform checks verify the Kubernetes objects that can be retrieved using the Kubernetes API. The node checks verify the configuration of the individual cluster nodes. In the video, we scan a cluster using the CIS for OpenShift 4 compliance benchmark. In the scan results, we saw that some of the compliance checks were failing. To remedy the compliance issues, we modified the configuration of the cluster to make it more compliant, and we also created a tailored profile. In the tailored profile, we set one of the parameters to make the profile work better in our environment. We also temporarily disabled one of the compliance checks. After rescanning the cluster, the compliance checks were no longer failing. And finally, we looked at the compliance operator scan results in the Red Hat ACS UI dashboard. I hope you enjoyed today's video. Please feel free to leave your questions or comments down below. If you found this video helpful, please consider subscribing. Until next time.